Farook, VSM Elena Geosystems, Mr. Pradeep Kirnapure, Chief Engineer, Hughes, Systique, Mr. Aman Gupta, Space Expert, and Ms. Nivedita Bhattacharjee, Senior Journalist, Reuters. You all may be seated, please.
Thank you.
Thank you. Thank you.
Pretty well. How many of us understand the space sector pretty well? Thank you. So we're going to talk about the confluence of the two. It's going to be an interesting discussion, and again, very, very warm welcome. We've got a very esteemed panel sitting with us here, and I'm going to introduce them, and I request them to introduce themselves as well as we get into this discussion. But first of all, I'd like to draw a historical parallel between the IT industry and space. In fact, in a way, I look at them as twins. And the reason I look at them as twins is because if we start looking at developments that have happened in space technology and in IT, we can almost see them running in parallel from a historical perspective. Some of us in this room would remember 50s and 60s were very exciting for space technology because of Sputnik and then Apollo 11. And it fired everyone's imagination. And you look at what's happening on the technology side at that time, we had the advent of mainframes. So tremendous amount of advancement that had happened. In fact, the mainframe played a very important role in man's first mission of Apollo 11. Some of you might have read it and so on. So some of us were alive to see that event occur as well. But over the years, things became even more exciting. From mainframes in technology, and that's an era which everyone in this room knows, we moved to PCs and we moved to the internet. And this was the 90s. So by the time we were in the 90s, the role that technology was playing in terms of the advancements that we saw from a data processing perspective and communications was second to none. And the role that IT started playing in terms of driving space technology accelerated very, very significantly. And the innovations in IT started driving how space technology would shape itself going forward in the future. And I think that is what brings us to the discussion here. The confluence of IT and space technology and how I look at them as a symbiotic relationship where there is very strong collaborative quotient between how IT is shaping space technology and how IT will help space technology to conquer newer unexplored frontiers that are unknown to us today. Many fascinating topics in many areas of space that IT influences, starting from satellite designing itself, going right on to the space missions, and then all the data that is collected and what we can do with the data, to many other important use cases which impact the common man. Many different facets we're going to discuss over the next several minutes that we are together. So I do hope they're going to find this as a very fascinating discussion. I'm now going to turn over to my panelists and invite them, and I'm going to hopefully make this an interactive session. As I said, if nobody's going to participate, we are going to cold call, right? All right, so we've got one friend who's bracing himself, fully well knowing he's going to get asked a question. All right, good. Pradeep, let me begin with you. You've been an expert in this area. You've done lots of things relating to space technology, the different facets of space technology. I want to go back to an era which I'm very familiar with and you're very familiar with, which is going back to the era when we had only one kind of satellite, which was a geostationary satellite. And then from there, we have evolved into newer kinds of satellite systems. We've got LEOs and we've got MEOs. And the LEOs and MEOs hover closer to the Earth than geostationary satellites. And I remember designing networks where we would actually deliver reasonable high quality voice data video using geostationary satellites. But we know that there were latencies because you need to ping a byte 36,000 kilometers up and then down. Life has changed with MEO and LEO satellites. Pradeep, you've seen all of this. Can you share what are the fundamental design considerations when you are designing for a system around a geostationary satellite versus LEO and MEO? What is the difference in the technical stack that you have had to consider between these two kind of satellite systems? And where do you see future excitement? So I'd love to hear your views. We'll kick this off and then we'll get around to asking more questions.
Thank you, Manoj. Let me thank SIA for inviting me to this panel. So let's begin this discussion. So to give a context here, the SATCOM system has evolved from the geo-based till MEO and LEO. Now everybody is talking about Starlink these days. Starlink is a new craze funded by Elon Musk. So that's a big hype everybody wants to do. So typically in SATCOM, there are three segments. There is a user segment. The user segment, it is the one where user terminals are being served. There is a space segment. The space segment has satellite constellation. In geo days, used to have only one satellite. Now we have thousands and 10,000 of satellites. Starlink is probably going to have 25,000. OneWeb has around 500 satellites. Again, Kuiper is going to have around 30,000 satellites in that range. So we are talking about 1,000 satellites in the LEO system. That's the space segment. The third segment is the ground segment. The ground segment has two parts. One is the Satellite Operation Center, SOC we call it. That's the one that will control the satellite maneuvering, telemetry, tracking and commands for that satellite. And there is also a gateway part, gateway system. That gateway system acts as anchor between the user space and the network. Because after all, what we want to do with this SATCOM? We want to communicate with somebody out there in the network. So this gateway acts as an anchor point for all this communication that originates to and from the user terminal. That's the context. Earlier, let me give an analogy with the terrestrial cell network. In terrestrial cell network, we have cells. Cells are typically radio coverage patterns transmitted by the transceiver. In the SATCOM, we have something equivalent. They call it beams. Beam is something that emanating from the satellite towards the user. So that's the area coverage. In the geo systems, we used to have very big cell, maybe thousands of kilometers. It's very broad. One spot we used to cover in my days, we say one geostationary can cover whole of the India. So 10,000 kilometers, that's the one single footprint. With LEO system, we have very small footprint. One beam would have, let's say, 50 to 70, 80 kilometers. That's very small. So look at the analogy. Earlier the beam was this big, now the beam has become small. Now with that complexity coming. So now let me compare the complexity that came in when you move from geo to LEO. Number one, the footprint becomes smaller. As the satellite height reduced from 36,000 to 1,000 kilometers, the velocity which the satellite moves around, the satellite will fly by your head within a couple of minutes. Before you realize, typically a call in the telecom world used to have 3 minutes or something. In 3 minutes, the satellite will pass through that. So you will need one handover. That's satellite thing. Now every satellite has 20 odd, 15 odd short beams. Now the beam will pass through every 10 seconds. So that's the complexity that's coming in. So earlier in geostate, we never worried about handover. Satellite used to be there. I used to terminally show that the satellite I talk to get to know that. So there is no need to worry about whom to talk to. And there is no need to handover. Handover is not never a part of system design in geosystem. Now handover is mandatory part. Every 10 seconds the satellite flies by. The spot beam flies by. So we need to handover. You have to plan the handover. The handover is the key thing here. That's the one complexity that comes in. Second thing about the tech stack. Earlier, on the tech stack.
Management plane component, all those things still exist there. So we'll have different models doing different ones. Somebody in power control, somebody in protocol part, somebody in the some model doing the application management part. So those things are there. But the scale has changed. Earlier, we used to have one satellite to talk to. In LEO system, we have thousands of satellites to talk to. With this scale, we need a server farm. One or two embedded server will not going to hack. We'll have at least 50 odd server in the backend to handle that much kind of load. The load is user traffic going through the gateway. Number two, the control traffic you have to handle every 10 of second. And the management plane, of course, there is huge data that will come. The stats are generated every second. So you have to look at what the stats are saying. You have to look at it. So that data gathering, controlling, and user plane. The whole of is a huge data. We need server farm. Earlier mostly used to be embedded system and everything implemented into custom chassis. Now it's no longer the case. Everything is virtualized software, and that is hosted on general purpose blade server. So the IT stack and the hosting environment has changed a lot. It's just like any other enterprise solution now. Earlier, the gateway software used to be a very niche space. People used to do embedded work in real-time OS and something. Now it is more application space. Of course, the physical layer is still there, but the layer 2 and above and control plane is all general purpose software. The last thing is, last aspect of system engineering is telemetry tracking and control. Earlier used to have one or two satellite operation center. One was the primary to look at the geostation, another secondary as a disaster recovery. The satellite never used to move. So one SOC was enough to control the satellite or gather data. Now there are thousands of satellites moving around. The one or two SOCs are not going to work. So what they have, they are coming with a distributed architecture. So there are lots of 50 or hundreds of gateways on the globe. So these gateways act as a proxies for the SOC. All the telemetry tracking and command data goes via the gateway. So gateway as a proxy. It will relay every information between the satellite and the SOC. That way the architecture of the satellite control has changed a lot. So that's another thing that came in. So with that, I close my discussion on this.
Thank you. Thank you. Very fascinating. From 36,000 kilometers, you come down to 1,000 kilometers. Everything changes from an architecture, technical stack point of view. And what you said is music to the ears of the IT industry, because earlier you didn't have to have a single server, and now you're saying you need hundreds of servers so that you can do the handoffs and so on and so forth. Very, very fascinating. I'd like to bring Brigadier Farook into the discussion. Now, Brigadier Farook is Dr. Brigadier Farook, but he's been very kind enough to say you can call me Dr. Farook, you can call me Brigadier Farook, and he said make it simple, you can call me Farook. All right. So Brigadier Farook, question for you. With all of this complexity, the reality of life is that when we look at the satellite ecosystem, the satellite, the ground station, and user equipment, something that Pradeep alluded to, all of this has to work in a synchronous fashion. How is this really enabled?
Good morning to all of you. It's a pleasure talking to the people. I worked in the armed forces more on multi-communication scenario. Satellite was, in our times, was not that much prevalent except for connecting to the remote areas. But today, as has been brought out by Pradeep, the height has come down. Lesser the height, more number of satellites. So it has got implications in many respects. More number of satellites. So earlier towers were part of your terrestrial communication. Now you are going to set up nodes. And nodes also, the distance between nodes is going to reduce. The management of the nodes, connecting the nodes with the ground segment and the space segment, one thing which is common is your time synchronization. As we talk now, you see your computer, you see your mobile, you see any of your workstation, they all must be time stamping. And you'll find surprisingly this time stamping is being done through our NTP server, which is internet dependent, and it is coming from United States. And this time stamping is very critical. Today you know that there is a lot of activities which is going on in IT sector. See, you have a log file accuracy, you have auditing, you do forensic, and so on and so forth, network fault diagnosis, and all these things are dependent on the time synchronization. And if there is a change in time synchronization, what is the amount of colossal havoc which can create in the entire network? It is not only in the civilian application, financial side, you take it, military application, launching of missiles, controlling of missile, deflecting of missile, you name a thing, you are there. Even your email. Okay, and something very, even you have, provisions to do something like signal network protocol to warn you that there is something is going wrong. Even that could be manipulated if there is a time synchronization is not there. So this is one of, I feel that I am now working in the geo segment, NAVIC related work, my company, I am an advisor in the company. And it is this aspect which has been taken very seriously by ISRO. They have come out with the NAVIC timing as part of the DESI GPS, which is already, the government of India has given a mandate that it has to be implemented in your mobile telephone by 2025. So when it comes to this thing, how do we achieve the PNT, and with particular reference to time, is going to be very, very important. And followed by that, there are many new technologies which are coming. Like, today, where earlier we were in legacy network, 2G, 3G, 4G and all. And as we progress, there are so many activities which 5G is going to come, 6G, then your IoTs. So what are those implications on this is very, very important. As you know, 4G is mostly dependent on tower-based communication. When you come to the 5G, because the larger the frequency, higher the frequency, higher is the bandwidth. Whereas what happens, the distant travel which you get becomes lesser. When you become distant lesser, the more number of nodes will come up. So the criticalities of maintaining the time in 5G assumes more significance as we progress in this one. For example, if you take an IoT device, if you take 1 square kilometer in a 5G environment, you will find that it's approximately 10,000 items will be found in 1 square kilometer. As you move to the 6G environment, it is going to be in 1 lakh items going to be functional in the same 1 square kilometer. As the number increases, the complexity becomes more. So what is the most important aspect is that the management of time, and that has to be firstly secure, it has to be accurate, and it has to be reliable. And this is what is one of the most important aspects which we should concentrate when we need to work, especially on the same segment. And also when there is an interoperability condition comes up with the satellite network coming from one side and your NTN, non-terrestrial, is coming from here and terrestrial network. Both needs to be integrated, and you need to have a gateway to work simultaneously. And when this thing comes up, the complexity manifolds. That's what I want to say.
Thank you very much, Brig. Again, I think the important thing is that how do we enable IoT, 5G, 6G and leverage space technology to be able to deliver on the performance, response times, and very, very important in terms of throughput requirements, which are very, very significant. Aman, I'm going to bring you into the discussion. I think one of the important things that we recognize, and Pradeep spoke about it as well, was around the fact that a lot of data is generated, whether it's through the space mission, or it is through, I'll pass you my mic, right? Don't worry. Either through the space mission, or a lot of data is gathered, by the satellites themselves. What is it that we can do to meaningfully drive insights from all of the data that we are collecting? What are some of the technologies that organizations are using today? I would like to really understand your perspective on the data side.
Hello, good afternoon, everyone. So, first of all, I would like to say it's a privilege and honor to be a part of this SIA conference. And as Sir asked, what is the role of the data and how the IT companies are utilizing the data in terms of giving the insightful meaning of the data. So certainly, as we know, there is a spatial resolution which is from low resolution 30 meter per pixel. We are moving to the high resolution of less than 1 meter per pixel. So as we are moving towards the high resolution, and so the data is becoming more accurate and more reliable and become more mature. So the data value chain, if we'll talk about, like we'll start from the data gathering from the satellite imagery or from the geospatial data, and we can start pre-processing, like we do the data fusion, or we'll apply the machine learning or the artificial intelligence algorithms. So we can produce the meaningful data, the output of it, which is the data visualization tool we use. Like we do we provide the heat maps or the graphs for the clients, which is required based on the requirements. So this is the one aspect. And if I'll talk about the tools, what are the IT companies are using, the leading organizations, like we are working on the deep learning algorithms, and we are working on the machine learning algorithms, and we are now focusing on Gen AI. So it's a subset of AI, but we are, even the world wants to work on the Gen AI side, and definitely I'll talk more on the Gen AI side. So this is the, I can say, the glimpse of the data side, what the organizations are doing in the space side, like we are doing from the gathering to the delivery of the final data to the clients based on their requirements from the agriculture, banking, or whatever the sector the clients belongs to. So this is from the perspective of the data side. I think that's it. Maybe if you want, we can talk about Gen AI.
Sure, we will get to talk about that in a minute, but I just want to continue on the data theme for a minute. And one of the important interface points when it comes to collecting data and trying to drive meaningful results out of that is a critical component in the entire satellite ecosystem, which is the gateway. And I want to bring Pradeep in because he's an expert in that area. So Pradeep, from a gateway perspective, what is it that you look at from a data point of view?
Yeah, let me bring in different complexity part that the gateway has to handle, because now it's a big data world. We do not talk databases, the traditional database anymore. Everything is a big data. We are talking about millions of terminals out there. Each of the terminals getting handed over every tens of seconds. So that multiplies every second. So million into 10 million records per second. And in a day, so add another 5 zeros there. So it is going to be lots and lots of records. So it's a megabytes and terabytes of data that is generated. So first, coming to the handover problem. So I said the terminals are handed over every 10 seconds. So how does that thing works? Who knows which satellite the terminal should latch on to? So there is a lot of pre-processing that happens, and there's a lot of data server that goes in. So typically, I'll give the brief. The satellite SOC publishes the ephemeral data, that is the movement of satellite in the space. Now we have hundreds of thousands of satellites in there. So we have the ephemeral progression or trajectory, the projected trajectory of the satellite in the space. That data is there. We look at the data and figure out whether where the satellite is going to be in the next 10 seconds. So we look at, and that is true for all the thousands of satellites. So we predict the position where the guy is going to be. Then think from the terminal point of view. There are all over the globe, there are thousands of terminals. So at every different location, there are different satellites visible. So pick up at a given location of the terminal, find out the candidate satellite that fellow might be seeing at a particular second or next couple of seconds. So find out the satellites, then figure out what elevation angle, look angle the terminal look at, so whether it is this way, that way. So here, if you look at it, the signal strength will be lower. Overhead signal strength higher. Up there, signal strength lower. So quickly the signal strength varies from lowest to the maximum to minimum. So looking at the SNR profile, the gateway decides out of the n number of satellites, which are the best candidate satellites to pick up over the head. We don't pick up something that far, we don't pick up something that far, we pick up something in this cone. So that is the look angle, we say minimum elevation angle. So pick up this angle, pick up the satellites and then tell the terminal, okay, you go ahead and lack under that. That is a PM2 kind of scheduling. That's where the timing synchronization come in, Dr. Farook said. And has to be very synchronized manner. We have to tell the modems to get programmed a couple of seconds ahead of time, and everything happens in milliseconds, not seconds. Second is visible to us. The hardware works in milliseconds. Okay, now you turn on the transmitter, turn on receiver, keep the pipeline ready, send command to the terminal. He also gets ready. Both ends are getting, and then just switch out the same. So this is called synchronous handover. That needs a lot of processing in the back end. The terminal does only the slave work of that. The gateway does lots of pre-processing and commanding work. So that's the key part. So that's the big data part. Another thing I will bring it, the interesting aspect is weather aspect. That's true for all the geo and LEO and something. With LEO it becomes little complex. Weather plays a very important role in the coverage. You may, we have your own VSAT or dish TV. You know, there is a rain fade and there is full blackout. Now this rain fade impacts the satellite communication very well. And typically this lasts for hours, couple of hours. The whole area goes away. So now if let's say there is some distribution partner, he is monitoring the service and there is a lot of SLAs involved in that thing. So that guy say, okay, there is no coverage in your area. Should he pay penalty or should he not pay penalty? Is it a natural thing or it is a man-made thing? So then we help those operators that it is not a man-made thing, it is a natural thing. And there is an exclusion in the penalty clause. So what we tell them, okay, in the particular beam, that beam was impacted by rain fade. How do you know that? Okay, again coming back to big data processing. Every sub-second we gather a lot of SNR data. Every satellite is transmitting a beacon signal. The beacon signal is supposed to have a reference level. So what happens if we say there is an abnormality, there is a analytics part in there is some abnormality in the pattern. So there is a pattern like this. So detect that pattern using some machine learning algorithm. Once you detect there is a pattern, that's a drop in SNR. Okay, there is something that is happening in that particular location, that beam. What do we do next? We do look up all the weather reports. There is a lot of services like weather.com, tomorrow.io or IBM. So we go and query those guys. Okay, report me the rain conditions in the grid around that area. So that guy will report, okay, every 5 kilometers report. Then we look at, okay, this the slant path. Was the slant path was hit by the rain there? If the slant path was hit by the rain there, then okay, that particular area is impacted by rain. And then you tell the distribution, okay, that part is rain affected. There are tricks there. Typically, there is a rain height. If the clouds and rains are above that time, there is no precipitation. It will not impact the slant path. So you have to pick up the right path. So this way. So only when the slant path hit the rain cylinder, we say there is impact. You may cross the rain cylinder without being impacted. There are lots of age conditions. You look at the age condition and tell whether there is real impact or not. So that's another big data processing that works in there.
Right. Thank you, Pradeep. Again, as you said, many complexities have to be kept in mind, and many different data elements need to be put together before we make decision in terms of how you are actually going to get the user impact and benefit of the specific satellite system. Nivedita, let me bring you in. We've spoken a lot about technology, some complicated topics. Pradeep almost needed a whiteboard here. And the next thing he would have done is gone to an algorithm and then gone around the room to understand, to check if anyone's understood that. All right, so let me bring you in. Let's lighten the mood up a little. The reason why we have all of these systems is to make the life of man simple. What is the societal impact of these satellite systems, of these missions? And how does IT and space come together to create that impact for the common man? We'll give you a better mic.
For sure, and thanks for that question. So something that, when all of you were talking, something that popped up in my head was, it's very telling to my mind how, when we're talking about the impact of IT and space and the confluence of both, the word that keeps on leaping from every corner is data, processing and analyzing of data and huge, chunks of terabytes of data, right? It's not a secret, like space missions have always had a profound impact on society, like be it communication, be it disaster management. ISRO's GSAT series has been, helping, help farmers with precision farming, help, better your navigation systems, help, better your comms, and apart from also the civilian, impact of this, how a lot of this is also, maybe not so much precision farming, but the others, how a lot of that is flowing into, realms of defense, realms of, being, getting ahead in the political game. So the impact is, in that sense, that is where we're looking at the impact. And let's not forget that, we are now very, very fast. We have moved away from a situation where it was only the government organizations that were talking about this. Now we have companies like, there's Pixel that is generating its own data. There's Galaxy, there's other Hughes and other, very, very industry specific and big name heavy hitter players who are coming in. Kuiper, Reliance, all of them are getting into the commercial SATCOM space. At the end of it, all of it will need support from IT to, make sure that the systems are working and in fine order. Because if it's not there, at the end of the day, if the end customer is not getting, if their phone is not working, to oversimplify matters, it's not going to work. They're going to not understand what the technicalities are behind my swiping up or down. They're just going to say, hey, this is not working. So is my servicing in, fine form. And, it's not just about talking. I think, we have moved, as various industry reports also show, to end, I just wanted to also flag the point that, I think now we have moved beyond just talking about, is this possible in an altruistic fashion, to looking at the very real commercial aspects of it. I think, by SIA, Satellite Industry Association, calculations in 2022, they said that commercial satellite data was like 73% of all commercial space activity in the world, and that was like upwards of $250 or $280 billion. So that's a lot of money. So there's a very real impact on humankind, and it seems like, there's a very real impact in terms of business as well.
Yeah. No, thank you very much. Again, you brought the societal impact and business together, and you spoke of a variety of firms which are jumping in because they see that business opportunity. One of the areas I think which is close to the heart of all of us, particularly here in Delhi with the rising temperatures, I was reading today that the air conditioning manufacturers have decided to upgrade.
As you know, the Indian constitutes 2 to 3% of space economy, around $8 billion. And the total economy they are trying to achieve for the next 10 years is around 10% market share. They want to rise with the 10% market share. And by 2040, the Indian wants to achieve $100 billion space economy. So with this, they want to achieve the sustainability goal as well. So the India has a commitment to reduce around 1 billion tons of CO2 emissions. And with this, the sustainability comes with the IT. So the IT, what I can say, we can collect the data from the satellites, and we can try to reduce the carbon emissions. And how can we do this? So I will give 2 examples for that. So maybe I'll give one example of the aviation sector. So like aviation sector is producing around 1 million tons CO2 every year, and it is quite huge. And we are trying to reduce, and there is some commitment from the aviation side that we are going to reduce these carbon emissions by the next decade. So how they are doing it? They are collecting the data, they are optimizing the flight path or the flight route which is available, and try to reduce the fuel consumption, okay, with the using the data. And if I talk to the second point of second example of the sustainability or the IT, I can talk about the security or the surveillance. So what we are doing now, we are taking the data, we are using the data to monitor the borders or the areas where we need the security instead of, and it is removing the human intervention. So that is also one of the things. So these are the two things what I can talk on the sustainability side.
All right. Before I kind of come back to the panel, just a question for the audience. Anyone wants to share any profound impact that you think, societal impact that that satellite systems can play, and particularly the role that technology can play in helping satellite systems achieve some of the societal goals? Anyone wants to share? Nivedita did a great job in terms of sharing a raft of very important areas. Anyone in the audience wants to share something that we've missed out? You can raise. Yes, sir. Please go right ahead.
So one of the best use cases for me is for rural areas which are remote. There is no last mile connectivity.
No last mile connectivity.
That's where maybe satellites like Starlink or some any other satcoms could
Connectivity.
help those and sort of.
I can tell you, Pradeep and I were talking before this panel discussion, and this was one of the earliest use cases that he and I spoke about. And the time when I got into this industry, and people would say, why would we need to use satellite networks at all? The first use case we used to talk about was exactly this. I'm very, very happy that decades later, we are talking of the same use case as being having one which has a very positive impact.
Yeah, and hopefully, right, so earlier on, right, there wasn't much traction because the commercials were not working out.
No,
right?
there wasn't much traction because there were guys like me. Now there are smarter guys like you. So generational shift makes a big difference. Yeah, I'm absolutely on it. We failed. So hopefully you guys will succeed. Make it happen.
Thank you.
Right, that's a fantastic use case. Any other, please? Yes. Forest fires. Forest fires. This is a very interesting use case as well. Well said, sir. Disaster management has been the classical one where I think we have done well as a country in terms of leveraging satellite networks and the role of IT and satellite together to really tackle disaster. And in fact, some of the early use cases were because, unfortunately so, of the disaster. I mean, we should have been proactive. We were reactive, but at least it helped, in avoiding future and helping mitigate risks in the future. Any other areas? Yes, sir.
Impacts of space weather on protecting power grids and aviation and communication side, exploring, making space safe and sustainable.
Absolutely. Sustainable, right? The same thing Aman was talking about, aviation, sustainability. I think that's, and again, power, right? Yeah. Saving power grids is what you're talking about. Yes, sir.
Precision agriculture.
Yeah, precision agriculture. Nivedita spoke about that as well. And that was a topic which was also spoken about in the opening session as well. Yes, ma'am, you're right there. Sorry, can you use a mic because people can't hear you? Yeah.
So I'm a student and we both worked on this. Harmful algal bloom detection using satellite imagery.
Very good. Excellent. Fantastic. Excellent. Yeah, congratulations. Great job. One round of applause for the ladies for being brave to choose a wonderful use case. Any other use case? And I'm going to come to Brigadier Farook after this with my question. Yes, sir.
The possibility that in the future there will be wireless servers orbiting us on the higher orbits, and that could be downlinked. Now, instead of uplinking, it will be downlinking to the ground.
Pradeep is very happy. He has a job for many, many years if this happens, right?
Because as you spoke, the temperature gradient of operating a server in the space is much different rather than working it here and working it into the
yeah, absolutely.
sea.
So Aman is also happy. Sustainability, right? He's talking of sustainability. You are saying why then should servers be on the ground? Just take the servers up and the ground station can actually pull the data. And then you need a lot of more servers here as well, right? To manage that data, right? Or all of that will also happen in space.
In the Earth, it is
1,000 kilometers away.
In the Earth, it is all about running efficiently with higher power. We have to have cooling station. We have to have
Correct.
power drop.
So out
from
there, God is taking care.
everything. The sun will
Upward
take care.
delegate to God. You cool all these servers. You take care of carbon emissions. Let them not happen here.
All right, very good. I think again, brilliant, fantastic. Thank you. Anyone else wants to share one more? Yes, sir, go ahead.
Sir, we are traveling all the time and we are able to communicate with the people. Only one travel we are not able to communicate with others. Is it possible to rectify that?
One travel we are not able to communicate, which is?
If you take your cell, wherever you travel, you can communicate. Only once we cannot use our mobile phone.
Where can't you? You can use mobile phones everywhere.
In air, if you are traveling, we are not able to use
just
it.
pay, that's all. They're happy. See, this guy is the gateway guy.
So when it will come to India, sir? When it will come to India?
He's saying, do it, please, because he'll earn a lot of money, you know.
Technology is there.
Technology is there. All right.
Thank you.
Yeah, someone has raised their hands. Yes, ma'am. Please go ahead. Yeah, we'll try and get a mic to you, ma'am.
There's a very niche and upcoming use case I would like to highlight. This is related to quantum security. So people have been, there are a couple of missions by universities, ISRO themselves is working now, that how you could leverage satellites to bridge or connect to long distance data centers, power grids, for providing highly secure keys.
Yeah, very well said, ma'am. Actually, when we were getting together on the panel, I was asking, do we have anyone who's an expert in quantum computing? And everyone shied away. I'm glad that you brought up the topic because I'm going to bring you back in the discussion towards the very end.
Yeah, so we are a young startup with the name Pramatra Space, and we are working on quantum security.
Very good, excellent. Now, we're going to bring you into the discussion in a minute, but first let me come back, Brigadier, to you.
Just to add,
Yeah, go ahead.
another important use case you might have missed out. The new Apple phone, it allows us to send a SOS signal via satellite. If you are in remote place and you are in emergency situation, the only way you can communicate is via satellite. And that's why in the US, they mandated to have satellite connectivity as part of the emergency services. And with 5G and above, it's going to be mandatory. Every phone has to have a satellite connectivity for emergency service. Send a SOS via satellite, if you have no other way.
Yeah, fantastic use case. Thank you, Pradeep, for bringing this up. And I want to come to Brigadier Farook here. He mentioned about a very important use case in his earlier discussion, which was around PNT. And all of us use PNT systems. We use them every day. We use them. I'm sure we used it to get to the venue here as well. Given the geopolitical situation, Brigadier, and given security considerations, when you look at PNT as an area, what is it that the government is thinking? What is the approach that the government wants to take? And I'm going to pass the mic on to you. Well, love to hear your perspective.
Thank you, Manoj. I think you eased the tension from our the people who have come here, because you've thrown the question to them and we are relieved to a great extent that now there is attention. So to answer your question before going to the what the government is doing, there is one thing which we all must understand, that what is the existing PNT which is happening in India, number one, and then what the government has done so far on the PNT front, and then we'll go to the question of what is government is doing with the new technology which is coming in terms of communication. So I'll answer your question in three parts. So first thing is that we all know that the GPS is the one which is providing your complete PNT solution as of now. And you know there are, GPS has got 31 satellites and they are in the orbit of MEO, that is medium earth orbit satellite. Out of this 31 satellite, 24 of them are being used to cover the whole world. And 7 of them are kept as a spare. Okay. And if you come to specifically to India, is this GPS, we have never questioned that GPS is giving you service. You are going from place A to place B. We are not bothered about the accuracy. You put it North Avenue, you will land in President House. You will not go to RML, you put it, you may go there, and then you keep roaming around and asking for that. And why this happens? Because the accuracy in terms of the meters is a questionable thing. And none of us have questioned because we were very happy it is coming free to us and using it well. So what happens is that India falls in the equator region. If you see the world map, GPS has been designed by the US Air Force for the region, tropical region and to some extent to the polar region, both in the south as well as in the northern hemisphere. Whereas what is happening is that when it comes for usage in India, there is a lot of dispersion and blind spot which comes up for a code. And every satellite out of this 24 satellite, in one spot it 2 satellites footprint comes in a day. So whatever loss which you are using is never measured, but this has been now analyzed and scientists have come out with the thing, and ISRO has done this 10 years back. And in addition to this, there is a strategic reason. When I was part of the Kargil operation, GPS input was denied to the Indian Army. We were not able to exactly use the Bofors to the target which is across the border. For whatever time that cannot be even brought out. But when this is done, our think tanks thought that it is time for us to analyze this and come down with a new proposal that how IRNS was born.
Which is NAVIC.
Which is NAVIC. See, this is a regional navigation satellite system, Indian regional navigation system, and nicknamed as NAVIC, Navigation Indian Constellation. Now I will cover what is Indian Constellation. Indian Constellation has got 7 satellites. And 7 satellites are in geosynchronous orbit, which is, as covered by Pradeep, it is at 36,000 kilometers. Now the ionospheric loss, because of the distance which is involved from 36,000 to the ground, there is a heavy loss because there is more losses are there. But thankfully, all these 7 satellites are spreading their beam into India only and 1500 kilometers from the center point. That means from India, 1500 kilometer total side, we are able to cover this. This is the plus point of this one. So when you have this satellite, it has been first. Second thing is that it was made functional in 2013, 10 years, 11 years back. And in order to improve the augmentation of the accuracy, we have gone for a Gagan satellite, which is a 3 satellite, which was simultaneously launched in order to get accuracy for the GPS. And that Gagan satellite is available for IRNS to do the correction. So our accuracy by far, by the ISRO chairman and our scientists have proved that the accuracy of NAVIC is much better for our region than compared to the GPS. There are scientific papers are there, I can share with you, or you can visit Elena Geo webpage, you will be able to get that information. Now come to the important aspect of the TNT. Now, positioning, navigation and timing. The timing part I have covered earlier, that how do you get the timing? The timing has to come from the satellite. So the atomic clocks, where he was telling what is the drift, 1 billionth of a second is the accuracy which is required in atomic clock. Not second or million, 1 billionth of a second. So that much of accuracy it can be derived only from the atomic clocks. And that is what is now, through the NAVIC, we are giving it to Indians and it is going to be implemented very shortly. As far as now we are concerned, whatever timing you are using through the internet, this is through the NTP server of the US, this one, which is not at all comparatively. It is meeting your requirement. And since there is a lot of thing in satellite thing, so much of problems in the communication. The one important thing which Chugh was asking was that where all it is used. There is a strategic space command which has been created recently. You all know that. Space command means space battlefield has come in Indian scenario. Space battlefield means the communication has to be based more on satellite. And satellite, this is also called non-terrestrial network, NTN, you must have all heard of it. Now I'll cover the government initiatives, what all they have done it. Now in order to understand the government initiative, firstly we must know what all the latest communication technique which are going to come into play. Now we are already in 4G, 5G to some extent, and still we are using the towers. But I covered in the initial stages only that towers are not going to exist anymore. As we move for the frequency, second range of frequency in 5G and then later moving on to the 6G, the nodes is going to play an important part. And higher data rates, more the data rate, the closer is the nodes. When you have so much of this thing, the accuracy has to be much, much better. And that is going to be achieved by having the clocks from the atomic clock. Now, in order to cater for this, government has done it. Number one is 3GPP, you must have heard it, third generation partnership, personal partnership organization. This is initially it was quite inactive. Now the DOT, CDOT and Ministry of Communication has activated 3GPP and there is a thing called 6G Alliance has been started. And these are the ones which are thinking. Then there is something called Telecom Standards Development Organization. This is now located in IIT Delhi. And in addition to this, Government of India has fought for it to have an ITU office in New Delhi. So what is happening is all this standardization, any development new thing, getting the patent, and Indian contribution is recognized worldwide, and we are able to generate new patent, new technique, new thing, everything is coming in. So government is doing a lot of things, and I am part of the TSDSI group, also 6G Alliance group, and there are a lot of the participation from the 6G Alliance, CDOT, and all this thing happening. And this is going to really make things better for when we are facing the communication in terms of interoperability and also of the terrestrial network and non-terrestrial worker together to come in the new environment. As I told you, when you come into the IoT stage, you want to use the IoT stage. What happens is that it is not the positioning which is in the horizontal plane is enough. You require, like if you are in a house you have in the third floor, you want to exactly know where the AC of the third floor is there. So the position is more important in IoT. You want to switch it on, switch it off. So that type of precision will come when you bring in the PNT aspect, and besides that, bringing in NAVIC to bring the more accuracy.
Yeah, very good. Excellent. Thank you very much, Brigadier, for explaining in such great detail. As you rightly said, using traditional GPS, once you reach a location and you don't actually reach it, right, you have to figure out. The good news for civilians is that there's a panwala who we can go and ask, who becomes our final GPS, if you will. But obviously, when you're in the Kargil war, then it becomes a different challenge altogether. And thank you very much for sharing those perspectives. Nivedita, there's a huge need for the world to come together, because space just doesn't belong to one country. And I think as a country, we've always been propagating the concept of Vasudhaiva Kutumbakam, that the world is one family, the planet is one family. What is it that you think we should be doing? How can technology help us in terms of working closer together to solve some of these issues and problems?
Well, I mean, like you rightly said, and space by nature is global. No one country owns space, or, current laws withstanding can own space. But, I mean, as, we are talking about, all of the new technologies that are coming up, including GNSS, there is surmounting evidence that, countries cannot work by themselves to get ahead. It just doesn't happen like that. I mean, take, for example, disaster management. If you're talking about, examples of collaboration, to my mind, I think the ISS is still one of the biggest examples of collaboration in space. But even beyond that, disaster management, the International Charter for Space and Major Disasters, I think a couple or maybe 3 years ago, there were wild raging bushfires in Australia. And through this treaty, there were some 10 or 12 countries that came together, satellites from about 10 or 12 countries, constantly pinging and giving updated information, and which eventually succeeded in controlling the bushfires and, stopped it from creating even more havoc than it would otherwise have. That initiative has been activated over 700 times since it has been put in place. I think that was in 1998 or 99. So that shows increasing need for collaboration. There's also, climate change monitoring on the top of the mind for most, actors in the space and across regions, whether you're a specific private company or you're a government. Climate change monitoring is something that you just cannot, not talk about anymore. ESA's Copernicus program does that very well. I was reading somewhere that the Sentinel satellites are delivering up to 10 terabytes of data each day right now, and Copernicus is like free to use, obviously. ISRO and NASA's NISAR satellite is just going to do the same, exactly that, right? Like their aim, if I'm not wrong, is to map the world once every 12 days with the use case of, figuring out how glaciers are working, where are we losing, where is afforestation happening, more deforestation, things like that. So, collaboration, I mean, like I said, whether there really doesn't seem like there is any effective or sustainable path forward without global collaboration, and I think countries are increasingly becoming very, very aware of it, which is why we have the Artemis Accords, which is why and even global companies, private companies are taking cognizance of that and working towards that. GNSS, for example, that without getting into the weeds of how the technology works, and whether Sir spoke a lot about that, Brigadier Farook, but I think the bottom line takeaway is that even GNSS, which includes GPS and other Galileo and Beidou, whatever technology you're talking about, won't work if there is collaboration across countries and companies.
Yeah, very well said. And we have a lot of startups in this room, and I think it's going to be redeeming for them to hear from you saying that it is important for everyone to collaborate, and we just can't be very parochial about it. Of course, when it comes to defense security considerations, as Brigadier said, there is stuff that we need to do to protect ourselves. But by and large, when we start looking at the larger cause of humanity, there is a big need, big desire. And as you're saying, Nivedita, that the work has started, we've got some fine examples, and we need to continue to accelerate. I'm at the end of our panel discussion, and my last question, actually, I'm going to throw it to the audience. And that's why I said I'm going to start cold calling, right, if I don't get your help. And this is about the future. What are the future advances in IT that can create path-breaking impact for space technology? I know many of you are very actively in this area. So we'd like to get your views, because many of you are helping build the future. So we'd rather hear it from you than from hearing it from the panel. So who would like to go first? Yes, sir. Please introduce yourself.
Yeah, I'm Chandrasekhar. I'm working in ISRO. I'm Deputy Director from IPRC, that is in Tamil Nadu, the southern part near Capgemeni. My thing is, you have talked about GPS and other things, what it is existing in our system and it is helping the human society. We have developed in NRSC a site called Bhuvan. I think most of the people will be knowing that one. That Bhuvan site is having all the features of GPS. So, how to market it and how to have this one in the IT industry so that it can enable the common people, which is indigenously developed by ISRO itself. That can be a topic of discussion, so that it can be an alternative to the GPS. Suppose, as somebody has told, GPS is providing essential data to the common people, whereas this Bhuvan, what is developed by NRSC, by ISRO, can be tailor-made for the common people for all the applications, remote sensing, even for our positioning, all the things it can be used. So that can be a matter of discussion, sir.
Excellent. So you're providing an opportunity to some of our young entrepreneurs, students sitting here, to really come partner with you, take this technology, develop it further. More importantly, build use cases around the technology that NRSA has already been built. Thank you very much for that. I'm very happy that you're coming here to advocate the cause of somebody coming and becoming your customer. I can tell you, I've never seen the government being so aggressive, reaching out for partnerships to commercialize some of the ideas that you had. So I applaud you for bringing this up. Yes, yes, sir. Let's talk about IT. Future impact on space technology.
Thank you so much. This is Shrikant. I run a company called Blue Space. So the US, I think one of the problems that he stated was data management systems. So US Space Force utilizes a similar structure where they share data with all the industry and private in an operational way. It's nothing but a data warehouse, but they still give it in the form of controlled, managed things where even classified data is shared with everybody. So if we have a centralized database system like Boon or some whatever the Indian way, if it could be distributed between academia, industry, and partners in an open way.
You're an entrepreneur. You're running Blue Space. Just partner with him and let Blue Space go and lead and take it forward. Yes, sir. Right in the front, please.
Sir, Aman had mentioned that he wanted to speak something on generative AI.
Yes, we're going to come to that. As I said, I want to take
from a future perspective, I would, although I have something in mind, maybe, and he would have much better use cases for large language models, generative pre-trained transformers. Now we are already into it very deeply, all of us. But how do you foresee the use cases of GPTs and large language models in this space?
Right, we'll come to Aman right at the end. I just want everyone's inputs and then we're going to close with him. Because I had asked him to speak on, requested him to speak on Gen AI. But we'll come to that in a minute. Any other? Yes, sir. Advances in IT which will have a profound impact on space technology. Your name, please.
I'm Rajiv Gambhir. I'm part of the team.
I know Rajiv. That's why I want you to introduce yourself. I want to
Thank you so much. Yeah, long time, Manoj. Yeah. So, the IT sector in India is huge. It has been driven by leaders like you. We have reached this stage and we are internationally known for our IT sector. The space sector has been, ISRO has been the vanguard of the space sector for a long time now. The private sector is coming up. And to compete internationally, the IT sector could have an engagement with the space sector. This could happen across mission control. This could happen across digital transformations, happen across supply chain securities. There's so many other things where the IT sector could engage with that. And that's something which I'm willing to hear more about. Thank you so much.
Yeah, no, thank you very much, Gautam. And I think that that you have a very important role to play as an institution in terms of enabling this, because you've got people from space here, you've got startups, you've got people from technology here. So maybe one of the, what I could say, right, the to-do homeworks at the end of the time that we have together at this conference is to create such a forum and bring people together so that this just doesn't become an annual jamboree, but just becomes a continuum where people will continue to engage meaningfully. Of course, COVID has taught us we can do a lot of things virtually. So I'd really like to throw the ball back at in your court, that please do take the leadership. And we've got all the stakeholders here. It'll be fantastic if we can do so. Any last comment? Because I'm going to come back to Aman and we're going to wrap this up. Any last comment around advances in IT that you think can have a profound impact on space technology? Yes, sir. Last word to you.
Right. And TCP/IP.
Correct.
And if there is if there, the non-terrestrial gets to a point of adopting TCP/IP, or at least putting the packet, CCSDS packets in IP, it might.
You say that use TCP/IP as a protocol. My generation will be delighted, but not today's generation, right? So,
yeah, because earlier on, right? So in the old days, so the need for the data type was very
different.
Yeah, it was like control plane data, right?
Correct.
And there was not much care for data plane.
Correct.
But now, like considering like multimedia and real time
very difficult.
graphics, so-
CSMA/CD protocols will not give you the desired level of performance. So we have to look at those issues as well. But we don't want to go into a drawing board debate with Pradeep on some of these protocols, right? But thank you very much for making that comment. Aman, I want to bring you in on Gen AI, and Pradeep, you wanted to say something as well.
Yeah.
So shall we let Aman go first, or you want to go first? You want to go first, all right.
Continuing
Okay.
that, the next thing about IT would be just think of manufacturing the space, because there is a lot of effort and cost involved in launching the payload to the space. So think of doing 3D printing or manufacturing, whatever can you manufacture in the space and then integrate there. So just do the integration space and put it there. So that's the next thought in this space. People are trying that, thinking on these lines.
So you're saying manufacture in space and let
Integrate.
it be there.
Yeah.
Don't bring it to Earth.
Yeah. Don't worry about launching the satellite.
All right. Okay.
Okay.
Aman.
Yes, it's Gen AI. So indeed, it's a very interesting topic, and I think world wants to talk about the Gen AI. And even we are working up to some extent on the Gen AI. So as most of the audience has mentioned, most of the problems as Gen AI is having the tangible and intangible benefits, like it's a time reduction, cost reduction, and it's definitely having the boost in the production in the manufacturing plants. Either we can talk about the launchers or the satellites. So if I'll talk about the space segment. So Gen AI is very useful tool, as we know, like in terms of geospatial data we are having a mega constellations now, and along with that we have the launchers or the satellite designs. So with these three case studies, what I can say, like we can use Gen AI, like we can use those algorithms, more than 60% companies, space companies who are working in some or other form of AI and try to collaborate with Gen AI. So if I'll talk about the geospatial data, so the Gen AI is helpful, like they are reducing the cost in terms of or the time to provide to the customer. Like they are having some models, like we can say the machine learning algorithm we have some AI algorithms which are already in the system, and we can use those algorithms to provide the novel concept, what the Gen AI said. So I can say, if I'll talk about the mega constellations, what we have from the Amazon Keeper or the SpaceX, Starlink or OneWeb we are having, we have to optimize the design of the satellites. Already we are moving to the small satellites or the miniature of the satellites, but still it is need to the optimization, and where Gen AI would help in those terms. Yeah. So if I'll come to the questions, what I think the audience asked, so that is, so I think yes, definitely I can think about like the ChatGPT or whatever we are using, we can go along with the astronauts in the space, and definitely Gen AI would be helpful tool in the future, what I can say. Yeah.
Right, thank you very much. We are at the end of our time together. And I want to say a very big thank you. Please, warm round of applause for my fellow panelists for doing a great job. Thank you very much, guys.
Thank you very much, Mr. Manoj, and a heartfelt thanks to our panelists for providing such valuable insights during this discussion. Your perspective on space IT solutions and cloud architecture have been truly enlightening. So at this point, we would like to appreciate the valuable participation and contributions of our esteemed panel members. To honor their dedication and insights, we will now proceed with a felicitation ceremony. I now request Mr. Manoj Chugh to please come forward to felicitate our esteemed panel members. Mr. Brig Umar Farook, BSM Elena Geosystem, can you please come forward?
Brigadier from the not Brig.
All right.
Easier to say doctor, right? When it takes like maybe better to correct people, because our own army, they don't know. So,
Mr. Pradeep Kirnapure, can you please come forward to collect the felicitation trophy? Mr. Aman Gupta, space expert. And now please welcome Ms. Nivedita Bhattacharjee, senior journalist, Reuters.
she said Reuters. Yeah. Reuters is what I saw many years ago.
I work for Reuters.
And now I would like to invite Mr. Rajat Ali, SIA-INDIA Senior Advisor, to felicitate Mr. Manoj Chugh, Chairman at Manoj Chugh LLP.
Thank you. You can go like this and I can go. Thank you very much.
Once again, a very thank you to all the panelists. Now moving on to the next, I request you all to come forward for a group picture, please.
Nivedita, group photo.
Oh, yes.
Here, this is from.
Come for a picture with you guys. You're all together. Thank you. Thank you. Thank you so much. Thank you. But I really need to click on what. Okay. So